Hey guys, it's Mr. Bosher, and today we're just going to keep practicing domain and range. We're only going to do a few examples today, so I'm going to try to keep the video short. And the reason I'm doing these examples is because some of them are a little bit more tough than what you've had in your Alex assignment or the examples we had yesterday. And also we'll have a new scenario sort of pop up today as well that we didn't get to last time. So even if you think that you have domain and range down and it's pretty easy, just stick with me. Okay, because we will see some new things today. Alright, so let's go ahead and hop in. I think I'm only going to do 5, 6, and 7, and that should cover everything that you need to know. Alright, so let's look at question 5. In question 5, simply ask us to find the domain and the range. Right, we're going to just start with that. We're not going to worry about the function part at the end for now. So let's just focus on domain and range. Just like last time, we're going to follow the same questions. So when they ask for a domain, we're going to say, well, what values do we use for the domain? What kind of values do we use? Well, we use x values. We learned that from last time. Well, now that I know I use x values, I need to ask myself, what direction do x values go? Well, x values can go left and right. So when I write my inequalities, I'm going to say I'm going to go from the left to the right. And now we just need to find my left and right points. Okay? So when I look at the graph, I have a left point right there, and my right coordinate point is, well, to the right, right? All the way to the right. And now I have to say, well, what are the x values of these points? Okay? And we have two ways to do this. We can do it like we did in the last video, where I take the coordinate points. So I could say, well, what's the coordinate point on the left? It would be 2. Let me try that again. 2, 6. And the coordinate point on the right would be 16, 2. And I could say, well, my x values are going to be the first number in the coordinate point, right? Because x values always come first. So I would say I have 2 on the left and 16 on the right, just like we did last time. However, this is a little bit time consuming, and so we might want to try to find a shortcut. Right now that we know how the details work behind the scenes and we practice this a little bit, I will allow you guys to use a shortcut, and this is how you would do it. You would say, well, what's the x value of this coordinate point? Well, it's -2, right? Simple as that. You can just say, well, where am I at on the x-axis at that coordinate point? I'm at -2. And over here, where am I at on the x-axis? I'm at 16. That way you don't have to write the coordinate points every single time and then have to go through that process. It's just a little bit of a time saver. All right. So I know that my left point is -2, so we're going to replace that. And I know that my right point is 16, so we're going to replace that. But before I say my domain is finished, I need to check one last thing. I need to check if I need to put equals to on my inequalities, right? Do I need to add that line underneath my inequalities? And how do we do that? Well, I have to go back to my coordinate points, and I just have to ask myself, are they filled in or not, right? Did we shade them in or not? Well, if I go to the left, that coordinate point is shaded in. And if the coordinate point is shaded in, we said that we need to add the equals to from last lesson. If I look at my coordinate point on the right, it is also shaded in, so that one also needs an equals to. And there we go. Our domain is finished, just like last time. So let's see if we can remember how to do range. So first question we're going to ask ourselves is, well, what kind of values do we use for the range? Well, we use y values. So I'm going to write a y in my range just to get started. All right. Second question we're going to ask ourselves is, well, what direction do the y values go? The y values can go up and they can go down. So I'm going to say that my inequality can go from the bottom to the top. All right. And now we need to find that bottom point and that top point. So let's see. Our bottom point would be right here, and our top point would be, well, at the top, right? If we use our new shortcut that we learned, we could say, well, I just need the y value, since I'm focusing on range, of these 2 points. So what would be the y value? Well, for that coordinate point, it's 2, because that's where it lines up on the y-axis. And for the top coordinate point, it would be 10, because it hits 10 on the y-axis, right? That's how high up it is. So we can go through and replace those. My bottom number, we said, was 2. And our top number, we said, was 10. But before we say we're done with the range, we got to ask ourselves one last thing. Do we put equals to or not on any of these coordinate points? So I go and I check. What do the coordinate points look like at the bottom? Is that shaded in? That coordinate point is shaded in, so I'm going to go ahead and add an equals to for my bottom number. Now I check my top number. Is that shaded in? Yes. So I'm also going to say equals to for 10, right? Because we learned last time that if the point is shaded in, we have to add the equals to. Alright, pretty simple. The only thing that's different about this problem than our problems from yesterday is that a lot of the times our left and right points were the same points we used for the bottom and the top. Okay? This is an example of where that's not the case, right? When we look at domain, we used, one of the points was different, right? Because the left point was not the same as our top point. Okay? And so that can happen, and that's why I wanted to show you an example like that. But hopefully, if we just follow our directions, it's not that difficult, right? We just look left, right, up, and down. Now, what about the last question? It says function, question mark. Well, this is a review on what we learned a few lessons ago on how do we check if something is a function or not a function. Okay? So, whenever you're given a graph and you want to check if something is a function, we have to use the vertical line test, if you remember that. So basically, we're going to draw a vertical line and see, do we only hit one point on the graph, or do we hit multiple? So let's see, if I draw a vertical line on the y-axis there, I hit the graph once and twice. So because I hit the graph more than once, this would fail the vertical line test. And this would not be a function. So is it a function? No. And that should be a bit of review from before. Okay, it's just a chance for us to practice that again since it's been a couple days since we've done that. Alright, question 6. First thing it asks for is domain. So first thing we're going to ask ourselves is, well, what kind of values do I use in the domain? We use x values. Second question we ask ourselves, well, what directions do x values go? They can go left and they can go right. So we're going to write left and right. And now we're going to find out, well, where are the left and right points, right? So I have a left point right here, and my right stopping point is right there. And I want the x values of these points, so I'm going to find out, well, what are the x values of those 2 points? For my left point, it seems that it's -4, and for my right point, it seems like it's +5. So let's replace those. So my left point is -4, my right point is 5. Okay, but I'm not done, because I have to check that last thing of, do I put equals to on any of my inequalities? So let's see. My left point, was that one shaded in? Yes, it was. So that means that we're going to put an equals to on that point. If I go to the right, is that one shaded in? No. So I'm going to leave the inequality as it says. right? There is no equals to, because technically I don't actually get to 5. I just get really, really close to 5. And that's our domain, right? We're done with that. Now we move on to range. Range uses what kind of values? It uses y values. So we're going to just start off by saying y. And then we ask ourselves, well, what directions do the y values go? They go up and they go down. So we're going to go from the bottom to the top. Let me write this out again. We're going to go from the bottom to the top. Good enough. Okay, so now I have to go and find the bottom and the top. So let's see. My bottom point would be right there, and my top point would be right here. Right? I get stopped on the bottom at, it looks like -2, and I get stopped at the top at a y value of 3. So let's go ahead and replace those. So my bottom value was -2, and my top value is +3. Now again, before we move on, we have to see, do we add any equals to on our range? So if I look at my bottom value, is it shaded in? No, it is not. So we're going to leave that as just -2 is less than y. We don't have to add an equals to. But for the top, that point is shaded in, so we will add an equals to for the y equals 3. All right, and there's your domain and range. Now, is it a function? Well, they gave me a graph, and they're asking me, is it a function or not? So how do I do that? We use our vertical line test, and we just go through and see, do I ever hit the graph more than once whenever I draw a vertical line? So if I draw a vertical line here, I only hit it once, so that's fine. If I draw a line here, I only hit it once, so that's fine. If I draw here, I only hit it once, that's fine, and so on, right? Is there any vertical line that I can draw where I ever hit more than one point? No. So this would pass the vertical line test. Okay, so is it a function? Yes, because I can't make something that looks like this, where I had 2 points with one line. I always only get one, which is a good thing. That's what we want to see. That gives us a function. All right, last example for today, because it will show you something a little bit new. Because when we look at this, is there anything interesting about this question compared to other questions? The first thing we should notice is that we have arrows on both sides. Okay? So what is this going to do to our problem? Well, let's think about it. If I want domain, by this point we should already know that that means we're going to use x values. And now we should also know that x values can go left and they can go right. So if I look at my graph and I say, okay, when I move to the left, do I have a stopping point? And where is it? Well, this arrow on the left tells me that we go forever. So do we have a stopping point? No, right? There's no stopping point. We go forever to the left. And we go, okay, fine. We know how to deal with that. We just erased it, right? That's what we said in the last video. We just erase the thing if we have an arrow going that way. But then if I go to the right, do we have a stopping point on the right? No, because it also goes to the right forever because it has an arrow. So then I have to also erase that part of the problem. And I'm kind of left with like nothing, right? It just says X. So how are we going to write this out? Well, let's think about it. If domain is supposed to tell me all of the possible numbers that I can use for X, and I go all the way to the left and all the way to the right forever, are there any X values that I don't use? No. I use every single X value. Because if I go all the way to the left, I hit all the negatives. And if I go all the way to the right, I get all the positives. So we are going to use all real numbers. Any number that you can think of, x can be, because we can always go as far as we need to left and as far as we need to right. Okay? That's the new idea. Sometimes you don't have any stopping points in the directions that you're looking for. Okay? And if that happens, you say that you have all real numbers. So let's talk about the range then. The range is y values, right? We know that. And the directions that a y value can go is up and down, or the bottom to the top. So bottom and top. If I look for a bottom value, right? So I'm looking at, if I go downwards, where do I eventually stop? Well, as I go downwards, I find an arrow. So we don't have a bottom, right? It goes forever. So there is no bottom to the range, because it will always just keep going forever. And I go, okay, that's fine. I'll just go to the top. But as I move upwards, what do I find? Another arrow, just like the domain. So I also don't have a top. So when both directions don't have stopping points, what did we just learn that we have to write? We would say that we hit every number. So the range is all of the numbers. It's the all real numbers. Because technically, I can use any y value, right? This arrow right here goes forever. So if I want to get to 100 eventually, yeah, that line will eventually get to 100. It's not shown in our paper here, right? So any number is possible. Well, is it a function then? Well, let's find out. How do I test if it's a function? I got to use the vertical line test. So I'm going to go through and just try a couple. I draw this vertical line, only hit it once. I draw another vertical line, only hit it once. I draw another vertical line, only hit it once. No matter where I draw this line, I only cross it one time. So do I pass the vertical line test? Yes, we do pass. So this would be a function. All right, and that's the idea. Okay, I'm just getting you more and more used to domain and range when they don't look like just a regular line. Sometimes we have curves. Sometimes you have closed points and open points. Sometimes you have things that aren't even functions that we're trying to find domain and range for. And yeah, it's just a lot of practice, but we're using the same rules, right? The rules don't really change. The only times they like kind of change is when you have an all real numbers. Okay, and again, you only get all real numbers when both directions don't have a stopping point. Right? Left and right did not have stopping point. Bottom and top did not have stopping point. So we use all real numbers. Okay? Now, this topic does not have a great Alex assignment for it. Alex does not give you great like curves and things like that. They only really give you lines, which isn't super helpful once we try to get to harder problems. Okay? So today's assignment's going to be a little different. I'm pretty sure I worked out all of the issues and that it should be fine. But what you're going to do is you're going to go to your Canvas, and there is a link for a Google Slides assignment on your agenda. Okay? If you click that link, it should ask you to make a copy of a Google slide. All right? You're going to hit make a copy. And we'll let it load. And then you'll get something like this. You will have to turn your iPad horizontal to make it all show up. But basically, you're just going to match the domains with the graph that it matches for. And the range with its match. So if I look at question 1, I don't know what the answer is. I'm just going to pick something random. I'll say, okay, I think this is a domain. Just put that right there. And I think this is the range. Cool, that's my answer. And you just keep doing that, right? Be aware that there's also a second slide, okay, that you'll have to fill out. And then once you fill these out, you're just going to screenshot them and send them to me on Canvas in the next module. Okay, and I did explain that in the agenda. All right, so you finish these, you screenshot them, and then there's a little module over here where you just will, attach your 2 screenshots and then submit it to me. And that's the basic idea. If for whatever reason you can't move the pieces, you might be in slideshow. If you go to slideshow, you can't do anything. right? Because it's like you're presenting, so you can't edit. But when you exit out, you're allowed to edit. So just stay in this screen and make sure your iPad is horizontal, right? It's a long ways. That way you can see everything, okay? So I know it's not an Alex assignment. I know it's a little bit weird, but it should work fine. And this is better for you than the Alex assignment anyway, because it has some tougher problems, which is closer to your test, all right? So if you have problems, let me know. If you have issues with understanding the material, right? If it's more about like how do I actually find domain and range, I'm struggling, send me a Canvas message. I'll see what I can do to help you out. But other than that, good luck on the assignment and have a great day.